Welcome, students. Let us continue our discussion on the topic friction, wherein we were discussing about the topic on connected bodies. Proceeding forward to the next question, which says two identical blocks A and B connected by a rod and rest against a vertical and horizontal plane respectively, as shown in the figure. If sliding impends when theta is equal to 45 degrees, sliding impend means it will just start to slide when theta is 45 degrees. And determine the coefficient of static friction, assuming it to be same for both wall and the floor. So whatever may be the question, the first step in any problem will be to draw the free body diagram. So starting with the free body diagram of block A. So before proceeding further for the calculation part, let us first define the motions of the block so that it will be easy for us to determine the friction force, the direction of the friction force basically. So as it is said that sliding impends. So because of this gravity, this block A will try to move down the plane. And because it is moving down the plane and it is connected to block B via this rod, block B will be having its motion towards right side. So these are the directions of motions of blocks A and block B. Now, starting with the free body diagram of block A. So I will isolate the body A from all the support contacts. So this is body A. The first thing which we show on a free body diagram is a applied load. There is no applied load, but there is a cable or a string or a rod which is connected. So there will be one force as a tension in the cable and it should be going away from the body. So I will make this as T. Then we have self weight. In the question, weight is not given, but it is written that both the blocks are identical. So assuming the weight of each block to be W, I will write this as, make it as W as a self weight acting downwards. Then we have reaction from contact surfaces. So here if you see for A, this particular wall will act as a surface, and because it is a surface, reaction will be perpendicular like this. So converting it to into a free body diagram or showing it into a free body diagram, it will be shown like this as normal reaction, let us say N1, and then friction force as the block is moving downward, friction force will be going upward with a value of mu multiplied by N1. So this completes our free body diagram. Now, to solve or to write the equation of motion, before writing the equation of motion, we have to resolve the inclined forces. So here there is only one inclined force as per our normal coordinate system. Only one force is inclined, which is T. So resolving it into two components, X and Y. Angle is already given in the question that it makes angle of 45 degree with respect to X axis. So if this is 45, this also will be 45 by means of alternate angles. So here I will write 45 here. And if this is 45, this will become T cos 45 and this will become T sin 45. Now equation, that is equilibrium equations, conditions of equilibrium, summation of fx should be 0. I will get T cos T cos 45 plus N1 is equal to 0. Let this be equation number 1. Similarly, if I write summation of Fy is equal to 0, I will get mu N1 minus W minus T sin 45 is equal to 0. Let this be equation number 2. Now, making the free body diagram of block B. So for block B, again, I will isolate the block from all the contact surfaces. Then we have to show applied force, which is not there, but there is a rod which will be shown as a tension in the rod. So I will make a tension in the rod as T. Then self weight, as we have considered that the weight as W, here also I will consider to be as W because they are identical. Then reaction at contact surface. So as you can see from the diagram given, surface is horizontal, hence the reaction will be vertical because it is making perpendicular to it. So I will transfer it here in the fluid body diagram. This will be your N2. And regarding the frictional force, as the body B is moving towards right side, friction force will be moving towards left side, or to be shown towards left side with a value of mu multiplied by N2. Now, as per our regular coordinate system, the only inclined force is T, so I have to resolve it before starting with the conditions of equilibrium. So resolving it into two components. Angle is already given to us with respect to axis 45. So this will be T cos 45 and this will be T sin 45. Now, writing the equations, I will get summation of fx equal to 0. From this I will get minus T cos 45 minus mu into N2 will be equal to 0. Let this be equation number 3. And when I write summation of Fy is equal to 0, I will get equation as T sin 45 plus N2 minus W is equal to 0. Let this be equation number 4. So now we have 4 equations. Let me write all these 4 equations together. Now, what we could do is, I can find out value of N1 from this particular equation as N1 is equal to T cos 45. So it will be minus T cos 45. Now, substituting this value of N1 in this particular equation here. So I will get one new equation as minus T sin 45 plus mu multiplied by N1. In place of I will write T cos 45 minus W is equal to 0. And if I rearrange the term, I will get, therefore, W is equal to minus T sin 45 minus mu into T cos 45. Let this be equation number 5. Similarly, we also had equation number 3 and 4. So I will just write 3 and 4 here. Now what I will do is find out value of N2 from here. As we found out N1 from this equation, I will find out N2 from this equation. So I will get, therefore, N2 is equal to minus T cos 45 divided by mu. And I will substitute now this N2 in this particular equation here. So I will get one new equation in terms of W and mu as T sin 45 plus, in place of N2 it will be minus T cos 45 upon mu minus W is equal to 0. Or I can write, or W is equal to T sin 45 minus T cos 45 upon mu. Let this be equation number 6. Now, if you observe equation number 5 and 6, if you observe equation number 5 and 6, both the left hand side are W, and also it is given in the question that they are identical. That means if left side is equal, we can also equate the right hand side. Therefore, I can write, therefore, equating both the equations 5 and 6, I can write minus T sin 45 minus mu into T cos 45 should be equal to T sin 45 minus T cos 45 divided by mu. So I am just equating equation 5 and 6. This equation I got from 5 and 6. Now just rearranging the terms. We can see that t is common in all, so t will be cancelled from both the sides. Now, taking all the terms with mu on one side and the constant term on one side, I will get sine 45 plus cos 45 is equal to mu cos 45 minus cos 45 by mu. So on solving this equation, I will get 1.414 is equal to 0.707 mu minus 0.707 divided by mu. So if I rearrange this equation, I will get one quadratic equation in terms of mu, which is minus 0.707 mu square minus 1.41414 mu plus 0.707 is equal to 0. On solving this equation as a quadratic equation in calculators, I will get the value of mu as 0.414. This completes our solution. In the question, it was asked to determine the coefficient of friction between the wall and the floor. So the answer is mu is equal to 0.414. So you can see that again the methodology for solving the problem was same. First we draw the free body diagram. We wrote the equation of fx and fy. And in this particular slide, which is now in front of you, we have just made some mathematical adjustments. So by just putting the values from here to here and there, and solving it in terms of the unknown, we get the answer as mu is equal to 0.414. But again, the basics of the solving the question was same.